Watch Wes Work just did a great video about Edison where he broke down a lot of the diesel electric math. And I kind of want to cover some things in that video and explain some of the benefits and cons of diesel electric, because as Wes pointed out, there are definitely some applications where diesel electric doesn't make sense, but there's a lot of applications where it does. So why don't we look at this video here and just go through it.
This video has disclaimers. Disclaimer number 1. Before we get started, we're not fixing anything. We're just going to be doing a lot of talking. If that's not your cup of tea, no big deal. Maybe we'll see you back here on the next one. I want to talk about Edison Motors. They're a startup, if you want to call it that, out of British Columbia. They built a complete working hybrid diesel electric semi-truck from scratch, basically in a tent. And now they want to bring their product to market. So we're going to talk about how it works, why it's awesome, and then I'm going to derail the hype train when we look at the numbers. They want to sell their system as a retrofit kit for semi-trucks and other large vocational trucks. They're also developing a retrofit kit for pickup trucks. And there's something like 50 million pickup trucks just in the US. So if it works out, it could be huge.
Yeah, so I think the retrofit market makes a lot of sense. Why throw out a perfectly good truck if just your driveline's worn out? And for example, especially in the vocational industry, you have a lot of things that go on the back of the truck. Things like cranes, hydrovacs, gravel wagons, where your body in many cases can cost more than the truck. Why throw the whole thing out when you can just upgrade the driveline?
They have one working prototype. They're also accepting pre-orders, building a dealer network, courting investors, and generating a lot of hype, especially on social media. And that's good. That's what you have to do if you want to bring a product to market.
So we've actually built 2 trucks. The first one was our proof of concept Carl, which was a crude diesel electric. We learned a lot for what worked and what didn't work. We took those lessons and we reinvented Topsy, which just as of a couple weeks ago, just got its license plate, its VIN number, and we're just starting to move into the real world testing right now, which is exciting. As far as the investment goes, we're really not raising investment. We have told every venture capitalist pretty well no. We've told every single one that approached us, no, we're not raising any money in investment. We're going to focus on doing our testing first, and we don't want venture capital because they want to change the direction of Edison. And when it goes to the installers, that is a fundamental core of Edison, and why we are doing this is that I don't like the way things are going. We're showing everything on social media for what we do, because I think that as companies are going electric, they want to hide everything. They want electric to seem complicated because they want to put a lot of planned obsolescence into these trucks where there's $1,800 headlights. Things that you can only work on if you're a licensed technician, and it's only serviced by the dealership with expensive dealership parts. And I hate that, because electric doesn't need to be that way. You look at old equipment, it's simple, it's easy to work on. Any small shop could work on the old electric motors. I don't like the way it's changing. So we show everything we're doing online, very open, very transparent, because if you want the technology to be adopted, that's the way you gotta be. And the reason why we're focusing out and reaching out to installers and putting together a kit that people can put together in their own backyard is because I think you shouldn't have to go buy a $120,000 F-150 Lightning that can only be serviced by the Ford dealership. We need to put together a common kit. So when these big OEMs are trying to displace the small mom-and-pop shops, the old small mechanic shops, and only get serviced by the dealers, by dealer scan tools, I don't like that. I want to partner up with these small shops, make a reliable thing that anybody can work on, anybody can install. That's always been a fundamental core belief of Edison.
The problem is they're making some pretty incredible claims, but they don't have any real-world test results.
Yeah, we don't have real-world testing results. We've built this truck in under a year in my parents' backyard, and we've been sharing this journey as we go. We've been very clear this truck has not been in the real world. It's been in factory test, which only goes so far.
As far as I can tell, all the numbers they're throwing around are estimates in the best case and wild guesses in the worst case.
We've had to rely on other experts, other engineers that have put together their numbers, and we've had to run off of what other people have done in the diesel electric hybrids. Volvo has put their truck out. Other companies have put out their claims on fuel savings. We've done the math and we put out similar claims on where it makes sense. And if you see on the website, we have a wide range of between 5% fuel savings to 95% fuel savings. It's going to be dependent on the job, and we've always said that.
On their website, they say a retrofit kit costs a third to half the price of a new truck and provides 5 to 100% fuel savings.
Okay, so for the pickup truck, the estimated savings of 30% is an estimate based on math, some of the engineers we've talked to, some of the numbers that other companies have put out about their vehicles, but it's going to entirely depend on what you're doing with a pickup truck. For the second set of numbers though, between 5% to 95% fuel savings, that is for the vocational semi-trucks, not the pickup truck, and that really has a big way. For example, running down the highway, you're not going to see a lot of benefits of the hybrid diesel electric, but on a logging truck where you're uphill empty, downhill loaded, you could see 95% to 100%. So depending on application, between 5% to 100% fuel savings, I know that's a big range, but until we do real world testing, I can't give you anything else other than a big range.
But what does fuel savings actually mean?
No, when we mean fuel savings, I mean literally fuel savings. You're just putting less fuel in there at the end of the month. The fuel bill is lower at the end of the month. That's what savings is. It's not super complicated where we're trying to calculate runtime. It's just lower amount of fuel used.
Initially, I thought it meant an overall increase in efficiency as a diesel-electric hybrid, which would be incredible. But I don't think that's the case. I think what they mean is if your truck runs for 2 hours on battery power and 6 hours on generator power, that's a 25% fuel savings. If you only run for 2 hours, that's a 100% fuel savings, which is a very confusing and borderline deceptive specification, in my opinion. What they're basically saying is that their truck has 2 fuel tanks, and you have to fill both of them, but when you calculate the fuel mileage, you only count 1. Battery power is still power, and it has to come from somewhere, and it has a cost. So in the US, we use a specification called miles per gallon equivalent, MPGE, and that is a way to judge a hybrid or electric vehicle compared to its internal combustion engine counterpart.
Mile per gallon equivalent is a very valid tool when it comes to cars, but it's very hard when you get into the world of vocational trucks. There's no mile per gallon equivalent on logging trucks because it depends what your haul looks like. Heavy haul low bed trucks in the city, how do you compare that? It's easy with a highway truck because you can put it at 60 mile an hour, you can run it at 60 mile an hour, but that really doesn't count the benefits of where the hybrid is. It's hard to justify on a vocational truck. You need those real world numbers.
I suspect it's difficult for Edison to calculate that because they don't have any real world test results, but I also think they might not be telling us that because their MPGE is actually worse than before the retrofit.
We're not giving the mile per gallon equivalent because it's not worse. It's just, it's hard to measure what vehicle we're using. Logging truck, dump truck, what mile per gallon equivalent should we get? I think the best thing we can do is explain the benefits, explain the drawbacks, and then let people decide where it makes sense and model the individual use case.
Edison Motors has a YouTube channel, and they put out a lot of content. They've documented this entire development process. And they have a video called Diesel Electric Advantage, where they throw around a lot of numbers. And I've watched that video multiple times, and I cannot make those numbers add up. Now, the video's over a year old. That was before they built Topsy, so we'll take it with a grain of salt, but I still want to go through it. They claim that a semi-truck with a 280 kilowatt-hour battery can run for 2 to 3 hours on battery power, and then a 250 kilowatt generator can recharge the battery in 30 minutes. In the same video, they say a loaded truck uses 200 kilowatts of power to cruise at highway speed. If that's true, then I think we're looking at more like 1.4 hours of battery power. The generator on their truck is powered by a C9 Caterpillar engine that makes about 250 kilowatts of power. Charging a 280 kilowatt hour battery with a 250 kilowatt generator should take over an hour. But if you're charging the battery while you're still driving the truck, it's worse than that, because the truck takes 200 kilowatts right off the top. So now you only have 50 kilowatts to charge the battery. According to my math, that would take 5.6 hours to recharge. So whose math is right?
Yeah, so this is a video of the advantages of a diesel electric truck. Is when we first built Carl, and it was based around a logging truck, because we built Carl as a logging truck. And it was made on a lot of assumptions based on our local area, where it was purely spec'd out as logging. And since then, we've increased the generator size from 250 up to 350, and it can do up to 450 in a peak load demand for about 3-4 minutes if really required. But it was based on the assumption that you would be running out to the block empty, reloading, coming back down to the mill. But applications changed. More people reached out about more different vocational things than what we even planned on when we made that video, when it was just logging. And all of those vocational applications have different run times, different charge cycles. And yes, if you are driving flat out on the highway and running the generator, you're looking at about 200 kilowatt hours that you're consuming, and you're putting out 350, which means that you're only actually charging at 150, because when you're using the generator, the way we set up is that it will bypass the batteries and the extra amount will go into recharging. So yes, real world results may be wildly all over the place depending on what you're actually doing with the truck. But that charging rate of half an hour, if it has 280 kilowatt hours of battery and you're charging at 350, remember, you're not bleeding the battery down to 0%. You actually are leaving that battery at 30 to 40% to maintain battery life, and you're bringing it up to 80%. So in that range, parked is a half-hour charge. Sorry, I should have made this clearer in the video. We'll go a lot more into this engineering later.
I really don't know, but as far as I can tell, Edison's claims rely on 3 major factors. First, electric motors are more efficient than a traditional drivetrain. Second, the truck's going to be doing a lot of stopping. They can use regenerative braking to recharge the batteries. And third, a diesel generator powering electric motors is more efficient than a diesel engine powering a traditional drivetrain. Let's start with the most plausible factor, that electric motors are more efficient. You hear this all the time. People will say, electric motors have more torque, they have a flat torque curve. That is true, but it's not quite that simple. It comes with an asterisk. This is a typical electric motor torque curve. It is flat, which means it has maximum torque at 0 RPM, and that torque remains constant. The power is a function of the speed. So the faster the motor spins, the more power it puts out. It reaches maximum power at maybe 1500 or 3000 RPM, and that's not a very usable RPM range, especially for something like an EV, where we don't want to have a transmission and a bunch of complicated gears. But that's okay, because the motor can actually run much faster than this. There's a whole other side to this graph. This is way oversimplified, so don't quote me on this, but in an electric motor, torque is basically equal to current. Speed, or RPM, is basically equal to voltage. Power is torque times speed, RPM in this case. Power is also volts times amps. So volts times amps equals torque times RPM. The voltage is limited by physical factors in the motor, like the air gap and eddy current and lots of complicated stuff. It's also partially limited by the battery. The battery can only make so many volts. The current is limited by the wires in the motor. Just like any wires, they can only take so much current before they melt into a puddle. When we reach maximum voltage and maximum current, that's the maximum power, and that happens here at the base speed. At this point, we cannot increase the voltage or the amperage, so we cannot increase the power, we cannot increase this side of the equation. But using some electrical trickery, like field weakening and messing with the frequency, we can make the motor go faster. But in order to increase the RPM, the trade-off is we have to reduce the torque. Otherwise, this equation doesn't work. So basically, you can split the graph into two sections. There's a constant torque section and then a constant power section. We want the maximum RPM range we can get, but we're losing all of our torque. So the way we usually get around this is we just massively overspec the motor. That way we still have enough torque up here to get the job done. The consequence is we now have way more torque down low than what we really need. This is why we have Cybertrucks literally ripping their wheels off, and that's why the fastest accelerating vehicles you can buy are all EVs. They don't necessarily need all that torque down low. It's a side effect of needing torque up high.
Yes, the peak torque is only for a limited time, but that's really hoofing on it because you got to remember you're putting out 800 horsepower at peak torque. Cruising down the highway torque, it derates itself to about 500 horsepower. So you really don't need 800 horsepower all the time, 60 minutes out of every hour, because that's an insane amount of power. So yes, you don't spec your motor for that. You allow it to go to that for that off-the-line acceleration, for that 20-30 minute hill climb, but you're not running 800 horsepower foot mashed to the floor all day long.
Actually, the Tesla Semi has a pretty clever solution to this issue. They use two drive axles, like a normal Semi, but each axle has a different motor, or at least a different gear ratio, and one is set up for low-speed torque and the other for high-speed torque. They use a mechanical clutch to engage the appropriate motor at the appropriate time, and it can use either motor by itself or both motors together, depending on the situation.
The way we got around this is by having a 2-speed rear end, you know, your old standard 2-speed, and basically you've got a low range for the bottom end torque, and then as you're moving, it shifts itself into a high range. So rather than like the Tesla Semi, which has one axle at one gearing, another axle at a different gearing, we have both axles have two different gearings. The first axle will shift first, then the second axle will shift after that, so it's a smooth power band the whole way forward.
There is one more caveat with electric motors. They typically have a duty cycle. You'll see in the specifications that they'll have a peak torque and a continuous torque, or a peak power and continuous power. And the peak will have a time limit. So it might say 400 Newton meters for 30 minutes, 300 Newton meters continuous. That does not mean you can make peak torque for 30 minutes. What that means is that you can make peak torque for 30 minutes out of every hour. It's basically a 50% duty cycle. If you exceed that duty cycle, it gets too hot and you risk melting the motor into a puddle. The duty cycle also applies to regenerative braking. One more nitpick with the Edison axles. They claim they can produce 110,000 foot-pounds of torque at the wheels with 3 drive motors. They're only using 2 drive motors, so I don't know what the actual spec is, but they claim that it's more than a traditional diesel semi-truck, which is not true, according to my math. A 15-liter diesel engine makes 1,850 foot-pounds of torque. An 18-speed transmission has a low gear ratio of 14.4 to 1. With a 410 rear gear, that would be 109,224 foot-pounds of torque. So it's very possible that the Edison axles have more torque in certain RPM ranges, but from a dead stop, it's a dead wash as far as I'm concerned.
Okay, so to explain the amount of torque, it entirely depends. Now, in bull low, in low gear, at peak RPM, you could exceed it a little bit. But the problem is that actual starting amount, You're letting the clutch out, you're starting down at 1000 RPM, you're starting out of the peak torque band of the engine. So as you start out, your torque that you can actually reasonably apply is much lower on a diesel. And then yes, if you're in bull low at 1800 RPM, given it full throttle, you probably could put out a little bit more torque. But then every time you shift up a gear, you lose that little bit of torque. With the electric motor, you get that instant torque right at the bottom end, pushing you forward. That's been well demonstrated. If you follow a lot of these electric trucks, if you've seen the videos of us hauling with Topsy, she will outpull a diesel transmission and out-torque a diesel transmission just because of that not bull low. And that's where it comes into the efficiencies of the electric motor, is that in a diesel motor, your peak RPM band where you're producing max torque is very, very tiny compared to the electric motor that has a large torque band. Well, every time you start out with a manual transmission or an automatic transmission, you start out 1100 RPM, you're lugging on it, you're letting that clutch engage, and then you immediately get torque and you shift your gear, your RPM falls, you come out of the peak power range, you lose your turbo boost, you gotta wait for your turbo to re-spool, let the boost come back up, get enough gears, shift out, come into neutral, slowly slow down, and then get into the next gear, wait for your turbo boost to come back up. It's a very inefficient process compared to allowing an electric motor to just apply max torque right from the very start, smooth, flatline torque. That's where the efficiency comes in.
It's possible that their electric axles are more efficient. How much more efficient? I really don't know. Let's move on to the next most plausible factor. Regenerative braking can recharge the batteries and increase efficiency. If you're not familiar with regenerative braking, it means that the electric drive motors can be reversed and turned into generators, which slow the truck and recharge the batteries. It seems like free energy, which it basically is, but it's not quite that simple. In the case where you're hauling logs down a mountain, yes, regenerative braking could make all the energy that you need. But that is a very, very rare use case. You know, where I live, there's plenty of logging, but we don't have a whole lot of mountains.
So yeah, we're making trucks in British Columbia where it's incredibly steep, incredibly mountainous. It makes sense for where we're making these trucks. If you don't have the mountains, it may not make as much sense. Where it might make more sense though is in heavy city driving where you're accelerating between one light, you're using that peak power demand, that efficient torque to move you forward, and then you're using regenerative braking to slow down for the next light. So for heavy city work where you're incredibly heavy between the lights, might make sense. Logging where you're in steep terrain makes a lot of sense. If you're not in the steep terrain and you can't take advantage of the regen, might not make as much sense. That's why we say that estimated fuel savings really, really depends on the use case, what you're doing with the truck. The harder you work it, the more you're gonna save.
Edison says, the more you stop, the harder you work your truck in the hills, the more regenerative braking energy that you get. Which is true. However, it comes with another asterisk. The most efficient regenerative braking systems that I'm aware of can only convert about 60% of the energy used for braking back into acceleration. Let's say you're cruising at highway speed, you regenerative brake to a stop, then you accelerate back to highway speed. Even if we ignore air resistance, rolling resistance, all those factors, you still use more energy than you generate.
This is 100% accurate. You don't get all the free power. There's still rolling resistance. You can only recapture so much of the power. It's not free unlimited. You don't make just as much going down as you do empty, but you might save 60% of that, where on a normal truck, that's completely lost. You don't get that 60%. You have 0% savings as opposed to 60%. So it's not infinite free power going downhill and uphill. Physics won't allow that, but it's a lot better than not getting any power back.
Same thing with hills. You start at the top, you regenerative brake all the way down. By the time you get to the top of the next hill, you will have less energy than you started with. You have to, otherwise you have perpetual motion. The only way it works is in the logging case because they're loaded going down and empty coming back up. If you're the same weight or the same speed from point A to point B, you will use energy.
Logging is literally best case use scenario out here because you're going up empty, not using much power, and you're using the stored potential energy of the logs at the top of the hill to regenerate that power as that heavy weight comes down, lightweight going up. That's why we say in logging applications, theoretically, you could almost get to 100% fuel savings. There's other applications that they've shown this with mines around the world where they've made it hybrid electric, or they've used the regen braking, bringing the ore down to create almost free power going back uphill. It is the best case scenario. In other cases where you're just doing rolling hills, yeah, you might lose 40, 50% of that power to rolling resistance, but saving 50% of that power is still better than not recapturing any at all.
Yes, regenerative braking is more efficient than a traditional drivetrain. It is not as much more efficient as you might think. That leaves the most dubious factor. A diesel-electric hybrid is more efficient than a regular engine and transmission. The Edison truck is a series hybrid. A diesel engine powers a generator, the generator charges the batteries power the electric drive motors. There is no mechanical connection between the engine and the wheels. Edison says that's more efficient because the generator only runs at its most efficient RPM. Hybrid semi-trucks are not new. I looked through research papers on hybrid trucks. I could not find any information on series hybrids. As far as I know, no one's ever made a true series hybrid. They've always been parallel hybrids. That means that through a complex series of clutches and gears, there's some way to couple some amount of engine power directly to the wheels. That's true of the Prius, that's true of the Chevy Volt. As far as I know, it's true of every current hybrid semi-truck. The reason is simple. It's more efficient. This study by the Oak Ridge National Laboratory found a 7 to 8% increase in fuel economy was possible with a parallel hybrid semi, but no significant savings were found with a series hybrid due to the, quote, large efficiency penalties associated with converting propulsion energy from mechanical to electrochemical form and back to mechanical form.
Once again, I fully agree with Wes here. Our series hybrid does not make as much sense running on the highway. This study was for long haul trucks. On a long haul truck, you're up at 60 miles an hour and you're staying there for 2-3 hours at a time without shifting through the gears. You can gear your transmission, rear end, where you're running at the peak RPM of that diesel engine. So the generator's running at peak RPM and the engine's running at peak RPM without shifting. The comparisons are basically a wash for power. The advantage though is when you're in the city and you're accelerating off a line, you're not constantly shifting gears, you're always in that peak RPM. So the more city driving you do, the more off-highway driving you do, the more the series hybrid makes sense. The more long haul you're doing, the more a straight mechanical drive or a parallel hybrid makes sense.
I should mention that the study was based on computer simulations, not real-world testing. I suspect that's probably because no one's ever made a series hybrid truck that they can test.
No, we made the first series hybrid truck in existence and we're just moving on to our testing phase now. But there's a lot of series hybrid cars, and if we extrapolate that data from the cars, it's very clear that series hybrid is the winner in city driving and in stop and go driving, whereas on long haul distance, a straight mechanical or a parallel hybrid makes sense. So yes, there's no data for the big trucks, but you can extrapolate from what we found in the cars and the SUVs.
This study by the National Renewable Energy Lab shows hybrid UPS delivery trucks getting a 13 to 20% increase in fuel economy in real-world testing. Again, these are parallel hybrids.
This article really goes to show you that there is a wide gap based on what you do with the vehicle. At the start, it shows that when they're running around in the city, 29 to 37% increase in fuel savings, whereas on the road, on the highway, the fuel savings was much lower. So depending on what you do, the real world testing does vary based on the application.
Edison likes to compare their trucks to diesel locomotives, which are diesel over electric. It's basically the same setup minus the batteries. The problem is locomotives are not that efficient. Most sources claim 20 to 25% thermal efficiency. A traditional semi-truck is somewhere in the range of 30 to 40% thermal efficiency. They're basically twice as efficient as a locomotive. Trains have massive efficiency advantages in rolling resistance, air resistance, carefully controlled grade and speed. It's an apples to oranges comparison. The efficiency of a train does not come from the diesel-electric layout. I don't know what else to say about that.
We compare the concept to a locomotive. It's theoretically how a locomotive works. The big difference though in the efficiency gain is like we mentioned before. The big difference is ours is that we have that lithium battery bank that can give you that 4C rating that gives you that peak load demand and the 1 RPM. The freight trains don't have that, but it's similar as in you take diesel, you make electricity, you put it to the drives. Our efficiency doesn't come from that as much as it comes from that peak load demand, 1 RPM, increased torque, shove off the line, regen brake to slow you down. That's where the efficiency comes from, not from the drivetrain in itself.
The guys at Edison, they seem to be just baffled that nobody's ever made a diesel electric semi. I don't think they ever stopped to ask why that is. It's less efficient. It is. If anybody has any proof otherwise, I would love to see it.
The reason why we're baffled is that it is showing increased efficiency. In the cars, in all these series hybrids, like the Prius and all the other ones that exist, it shows a large amount of increased efficiencies. What baffles me is that every time a large OEM looks at it, they say, well, it doesn't make sense on the highway, so I don't know we're going to pursue it. But they're forgetting that the vocational market is 60, 70,000 trucks per year. And it's been demonstrated that in that application, this makes a lot of sense. What I'm baffled at is why the OEMs are ignoring the vocational market and just focusing on their bread and butter, which is general freight hauling on the highway. I get it. That market is easily 8 times the size, but this other market exists, and this makes a lot of sense for that market.
Let's move on to cost. Edison says this setup is going to save you money. They don't say how much. I'm sure it depends on a lot of factors, but the impression I get is that the conversion should at least pay for itself.
Yeah, the setup should really pay for itself depending on your application. Let's look at logging trucks. A logging truck uses about 500 liters a day per fuel. Fuel for diesel costs about $2 a liter here. That's $1,000 a day in fuel. Let's not take the 95%, but let's just take the 50% fuel savings from going up and down. That works out to $500 a day. That works out to $2,500 a week. That works out to about $10,000 a month. I guarantee you the truck is paying for itself in those economics. As we get into the 30% economics, it's still economically justifiable, especially if you consider that you have an older truck, the driveline is wearing out, and you need to spend the money anyways to replace that driveline for only a marginally additional price. Being able to have that fuel savings more than offsets the marginal thing. It even offsets a new truck payment. I guarantee you, on a logging truck, the amount you're saving in fuel is offsetting that fuel payment on those kind of hauls if you're spending that kind of money. It makes sense in certain applications. It might not make sense in other things. And now Wes talks about the pickup kits. The pickup kits are also going to be depending. Are you using this truck for 10 minutes a day as you drive to work and 10 minutes back a day from work, and you want a top-end, high-end retrofit? Maybe the economics don't make sense. If you're using it as a tow truck in the city and you're running it 12 hours, 14 hours a day, the economics might make a lot more sense. But once again, it really heavily depends on the use case.
Edison says 1/3 to half the cost of a new truck. At the time I'm making this video, EV batteries are about $150 per kilowatt hour. Edison's largest battery option is 280 kilowatt hours, so just the battery alone is going to cost $42,000. A new Cat C9 engine, that's got to cost at least 20 grand. A generator, battery management system, let's just say 10 grand. Then you need 2 electric axles. We'll just say 12,000, I have no idea. You also need to pay for installation. Again, I have no idea, but I would think at least 20,000. So we're over $100,000. I don't know what a new semi-truck costs either. I guess if it's 200,000, then Edison is right on.
A new logging truck now here in Canada goes for about $400,000 to $500,000 rigged up. And a lot of those numbers, those axles are probably about twice the cost. The C9's accurate. The battery prices on the top end battery are, yeah, around that price. But a lot of vehicles you can get by with having smaller battery pack. But yes, if you're comparing a $300,000 new logging truck, that $150,000 range is about a third of that. And if you're looking at a cost of doing a full rebuild on a truck with a brand new X15, brand new transmission, reman transmission, new rear ends, the price might only be 30%, 40% more than what you're comparing to doing the rebuild cost. It really starts making sense at that economics. But then, once again, if you're comparing it to a Freightliner Cascadia as a highway truck, you can buy brand new for about $150,000 Canadian. Spending $150,000 almost equals the price. However, if you compare a crane truck, where a 40-ton crane truck is $1 million, well, now you might be 20% the cost of a new truck. So once again, it really, really depends. I know that's an annoying, I wish I had a better answer.
What about the pickup truck kit? Again, I'm just guessing here because they haven't released any specs about this one. Let's say an 80 kilowatt hour battery, that's 12,000 bucks. You might use a small diesel engine like the Cummins R2.8. I think those are about $10,000. A 4x4 truck's gonna need 2 axles. Let's say that's 8,000. Generator, battery management, maybe 5,000. Installation, let's say 15,000. So that's $50,000. Now, a lot of pickup trucks now are up around $100,000. So again, that seems like it might be right.
Yeah, that's in the ballpark. That's why we say about a third, a half, because brand new F550s now are running into the $150,000 range, but bringing it down to a smaller truck, you're into the $80,000, $100,000 range. So that $40,000, $50,000 is in the rough ballpark of where we were hoping to be. But we're finding things like battery cost have dropped in half since we started this, but inflation is sending up the prices of other half. We haven't released exact numbers because it's still early on in the development. We're still just building these things now. We're working with DeBoss, Keybray, we're building the first few trucks. Once we have these first ones built and we test them in the real world and see if anything needs to change and what the performance is, we'll have a much better number going into the thing. But yeah, Wes is pretty well right. That is in the ballpark of what we're looking at. And once again, it depends on the economics, on what you're doing. If you're looking at just buying a brand new truck, yeah, you're already saving money by just rebuilding what you got. But if you're looking at maybe you don't need to retrofit, you've got a good truck, and you're looking at installing a $50,000 kit just for fuel savings, depends entirely on how much you're using that truck and what you're using it for to see whether that conversion makes economic sense.
I made a spreadsheet to help us with the numbers. There's a lot of variables. So let's just walk through some examples. Let's build a semi-truck. I'm going to use $5 a gallon for fuel. That's pretty close to the national average. We'll say it normally gets 7 miles per gallon. This guy is a real go-getter. He runs 90,000 miles a year, and he works 5 days a week, 50 weeks a year. The Edison kit costs $100,000. I'm not going to count the value of the truck before the kit. We'll just assume that it has no value. We're going to use 280 kilowatt hours for the battery. And I'm going to say the battery only range is maybe 100 miles. I think that's pretty close based on estimates I've seen. The truck still has an internal combustion engine, so there's still going to be a lot of maintenance, but we'll just say that it's $1,000 a year less. And you can see if we don't have any efficiency gains, like no gains in miles per gallon, we're looking at an 18-year payback period. and that's not very good. A 5-year payback is pretty standard for the industry. 3 years would be even better. To get to a 5-year payback, we need to increase the fuel efficiency by 45%. And I can tell you that is straight up never gonna happen. What about a vocational truck? That's where Edison says their kit really is gonna shine. They're claiming 70 to 100% fuel savings. Vocational trucks are dump trucks, cement trucks, service trucks. They mostly make local trips and return to the same place every night. They do a lot of stop and go driving. They also drive more with no load or partial load. So let's build one of those. We'll say it normally gets 6 miles per gallon. It runs 35,000 miles a year and 200 days a year. Kit cost is the same. We're going to use the same battery, same everything. You can see our payback here is 14 years. If we want to get it down to 5 years, we actually cannot do it, because even if we max out the efficiency, we never quite get to 5 years. Let's try a smaller truck, maybe kind of like a pickup truck. So we'll say that normally it can get 20 miles per gallon. It runs 20,000 miles a year, the same 200 days a year. The retrofit cost is going to be lower, 50,000. And we'll say the battery's 80 kilowatt hours, and we'll leave the range the same at 100 miles. Maintenance savings, it's going to be less, let's say $500 a year. There are no efficiency gains because this truck doesn't use any fuel. It runs all on electric power. But you can see our payback period is over 20 years. And this spreadsheet's not just a buzzkill for Edison. It works for pretty much any electric vehicle. So let's try a Cybertruck. We'll say it gets 15 miles per gallon, runs 12,000 miles a year, say the same 200 days a year. Let's just say a Cybertruck costs $35,000 more than an equivalent pickup truck. Battery size, I think, is around 125 kilowatt hours, and the range is maybe 250 miles. Leave that the same. It would take over 10 years to justify a Tesla just based on fuel savings. Now, if you compare that to a $100,000 luxury truck, it starts to look a little bit better. So maybe if this is only $15,000 more, that's a pretty reasonable payback period.
All right, so Wes goes through the numbers here on what makes sense in terms of economics with his spreadsheet, but we do have our own spreadsheets, and I'm going to let Eric, who's our chief technology guy, he's worked really hard with some very talented people to put together our numbers that give us a little bit more of a case study, because you got to factor in a lot of different variables. As we said, we have a really good model that factors in a lot more variables. We'd love to run through that with you.
Yeah, so what you see here on the computer, it's a model that I built. It's really trying to showcase the fuel efficiency of our vehicles. Everything from like a single axle, tandem, tridem, to like a whole bunch of different weights. It's pretty cool. I mean, it takes in factors like not only weight, it's got like coefficient of drag, traction forces, wind speed resistance. It's got grades on it. It's pretty damn cool. So let's check it out. All right, guys, so this is the model here that showcases fuel efficiency and fuel savings when operating one of our hybrid electric semis. What you see here is a Excel model. It essentially has a whole bunch of variables, which are highlighted in yellow, and then a whole bunch of outputs, cells, which are essentially these formulas. And the whole goal of this model is to showcase anticipated fuel savings based on a hull. In this case, we're going with like a pretty heavy duty haul here. This is a mine haul between a copper mine that kind of goes down the hill into Vancouver and then back up fully loaded. It's a pretty heavy load, obviously, at 65,000 kgs, but just kind of wanted to showcase what a heavy haul application using the highways, how it could still generate a huge amount of fuel savings. So let's kind of dive in here. First things first, just kind of want to showcase, we're expecting about 13.6% regen on this one. So, you know, we're not getting that huge amount of regen because we're driving on the highway, but pretty important to consider because that's a huge fuel efficiency gain right there. I also have this really pretty graph here that showcases the real power consumption based on different speeds you're driving at. Obviously, you're not going at continuous speed all the time. So if you're passing somebody, you're burning a lot of power. But if you're kind of slowing down and stuck behind traffic, you're consuming a considerably less amount of power. But using all these variables here, you can see that if you're driving on an average speed of 110 kilometers an hour, and this, you know, simplicity, I'm just putting 0% grade, but this model can do up to, you know, 30 if you want to. But you're kind of expecting to consume about 187 kilowatts of power on average. What you do, and you kind of add on a few other little variables here for operating an electric semi, and boom, you get 190. So what I did is I just put that into our daily haul. So if you're assuming that you're driving 14 hours a day, you're getting a bit of regen. That actually turns into your estimated fuel burn. And to do apples to apples in this model, I got the mechanical version here in the red, showcasing that on a typical haul at this weight and this speed, you're burning about 665 liters a day of fuel. But if you end up using a hybrid truck like ours, you could be seeing pretty substantial savings of 449 liters per day instead. And you know, the reason behind these numbers, the big factor, you can actually see it on this graph here in the battery SOC. This showcases your battery state of charge over a shift. And it's really cool. So, you know, you end up having your truck fully charged because you charged it, while it was parked the night before. And then off you go. You start your shift. Start burning, obviously, a lot of power. But then once your battery gets to about 20%, the generator kicks back on and pretty aggressively over a period of about 2 hours recharges your batteries. And you know, when it gets back to 100%, no need to run the generator anymore. So it turns off, and for that whole hour, you're burning no fuel, just like in the morning. And this cycle happens a few times during your shift. It's in those moments where you're not having to run the generator, which really saves a lot of fuel for you. Because those hours, you're not burning anything. You're just using that extra power that your generator produced throughout your day. At the end of the day, obviously, you parked your truck, still got to charge it up, so you just plug it into the wall and boop, it charges right back up. What's really impressive here to note is, we were getting a pretty substantial break even or a payback period on your investment for one of these trucks because of the substantial fuel savings. As you can see, the 176,000 per year in fuel savings. That's if you're running your truck for 30 days a year. That's a huge amount of cash that you can stow away. And therefore, the truck does pay for itself in about 2.5 years, which is just really impressive. And this is what we want to see, right? These trucks are a bit more expensive than a typical truck, but because of its advantages as a hybrid, the hope is that it makes a very favorable investment. And yeah, I think the whole plan of this model is that we'll eventually make this open source. I want to be able to use it as a sales tool for all of our clients going forward. And most importantly, as we start driving Topsy on the road, I want to be able to use real numbers in this model. I tried really hard to use great physics analysis. Keaton and I have been really working hard on the math, but we know that models are never truly factual. You have to make a lot of assumptions in these things. So even if we're extremely conservative, eventually this model is going to have real world numbers. And looking forward in the next few weeks when we have Topsy running, we'll be able to fill in those blanks. But in the meantime, I hope this model really showcased the efficiency values of our truck based on the physics and the math, and really excited to prove these numbers in the next few weeks.
There's a ton of other challenges with the retrofit kit. Edison seems to be targeting older trucks that are solid but the drivetrain is worn out. I don't know where you find trucks like that, but it certainly isn't around here. On my old trucks, the drivetrain is tip-top. In fact, it's the only thing holding the rotten body and frame together.
When you look at this truck though, a flat tire and a rusty quarter panel may or may not be a good reason to throw a truck out. You can fix this truck. This truck that's in the video can be repaired, put back on the road. I don't know the level of frame rail rust. Maybe it's a good example, maybe it's not. But once again, it depends on the truck, depends on the application, depends on the level of rust and neglect. It's not for every truck, it's for the trucks that it makes sense for. But to answer where you get a truck like that, honestly, look at Ritchie Brothers. Look how many vehicles on those lots look like they're in really good shape. They're not rusted out, they're not anything, but you buy them and you get 30 kilometers down the road and you find out they've got a cracked head, or they dropped a liner, or their transmission's grenaded. They looked really good, but they've got blown motors, blown drive lines. There's a lot of trucks like that out there. And there's also a lot of classic trucks that have been well taken care of, but the motor is done. The motor is old, the driveline system kind of sucks, the fuel mileage is terrible, the power isn't what you should be getting for the mileage, but you still want to daily drive it. Like, it's if you got a classic OBS Ford that gets terrible fuel mileage, is a little bit worn out in the drivetrain, and you want the power and the torque of electric without buying a $120,000 Lightning, that's when this makes sense.
You're going to have to figure out safety things like ABS brakes and airbags. You're also going to need electric power steering, electric power brakes, electric heating and air conditioning. Newer trucks are going to have complex CAN bus networks that have to be dealt with. And every year, make, and model is going to be a little bit different. So there's no way to make a universal kit.
So we've got some absolutely amazing partners on this, people that have come out of the woodwork that are figuring out things like CAN bus. Yes, we have electric power steering. We have it for the semi-truck. We have electric air conditioning, electric heating. These are all things that you can get. They're all really becoming off-the-shelf components that you can order from suppliers. There is a way around all of these issues. They've all been thought of. They've all been put into Topsy. We're just getting the scaled down version of the pickup truck. The pickups are going to work exactly like Topsy, but scaled down. As far as the CAN bus integration goes on newer vehicles, yes, that is more of a challenge, but we do have some absolutely talented people that are experts in figuring out CAN bus, and we're going to keep working towards it. But yes, every truck, unfortunately, they're not like semis. Each one will be a little bit different. Some may have a little bit higher cost, some may have a little bit lower cost, some may need a little bit more CAN bus reprogramming, some might not. It depends on the truck, but these are issues that can be solved.
As far as I know, in my lifetime, no one has ever attempted to make an aftermarket, emissions-compliant, turnkey driveline replacement for a pickup truck, let alone a complicated diesel over electric hybrid system. That is going to be a monumental challenge.
Engine kits and engine swaps have been a thing for a long time. How many people do a Cummins swap or a Cat swap, as a case of DeBoss Garage on their F3 Kitty? Engine swaps exist, transmission swaps exist, there's people that swap out Jeep axles for 1-ton axles, and there's a lot of electric vehicle kits where old Volkswagens, Porsches, that were gas and they're making them electric. Those kits exist. There just hasn't been a kit for the pickup market. We're bringing out a kit dedicated to the pickup market. Nothing is really new. We're not doing anything crazy revolutionary. We're just putting a kit together for a market that hadn't had an EV kit before. I don't think we're crazy. I don't think we're out to lunch. I think there's enough engine swaps, enough EV swaps that putting that kind of same ethos together on this isn't very much of a stretch.
Does it qualify for tax credits as an EV or a hybrid? I don't think anybody knows. It seems like Edison's offering a complicated, expensive, questionably efficient retrofit kit that gives you some battery-only range and not a whole lot of other benefits. It feels kind of like a solution in search of a problem. On a purely economic basis, I just can't see how it makes any sense.
Besides the areas we already covered, where the niche applications where it does make economic sense, the other way it makes sense is that you have places that are mandating you take old trucks off the road. California, again, is one of them. They're starting to say that anything after 10, 20 years isn't allowed to be driven on their roads. So if they're mandating electric, full electric won't do the job of what 90% of people that have a truck for. The range extended electric does. Why does the economics make sense when you have to buy a $120,000, $150,000 brand new electric truck, but spending $50,000 to retrofit a truck you already have? Why does the retrofit not make sense, but buying a brand new one for $120,000 that won't do the job of 90% of people, why does that make sense? EV mandates are coming, and even as a standalone against the EV mandates, this makes sense. Or else we're just going to get a bunch of electric vehicles that can't do the job. They're going to take the old trucks off the road, and that's a damn shame that I don't want to see happen.
On the other hand, who cares? I mean, diesel-powered pickup trucks don't make sense for most people who buy them. It's virtually impossible to justify buying a $120,000 Cybertruck, but Tesla can't build them fast enough. If we bought our cars based on a spreadsheet, we'd all be driving a 20-year-old Honda Civic. There's a lot more to it than just the numbers. I hope this didn't come off as mean-spirited or anti-Edison. Like I said, I like those guys and I like what they're trying to do. There's definitely a lot of enthusiasm and excitement about the project. I hope that more small companies get into the EV market. You don't need to have a multi-million-dollar R&D budget to have a good idea. I know that Edison and DeBoss Garage, they're hard at work on more prototypes. Hopefully, we're going to see some real-world test results coming out soon. Maybe at that point, I'll make a follow-up video. And if there is crow to be eaten, we'll take care of it then. I'll put links to the Edison Motors website and their YouTube channel. I'll put links to any of the papers that I cited, and maybe I'll put a link to the spreadsheet so you guys can play around with that. Let me know what you think in the comments. If I screwed something up, which is highly likely, I will put corrections in a pinned comment. So thanks for watching, and I'll see you next time.
No, I really want to thank Wes for making this video. I think he made some absolutely amazing points. There are applications that absolutely, this doesn't make much sense. And there's applications though where it does. So I really want to let people know that take everything with a grain of salt. We're doing real world testing. Look at your use case before you decide on something for you. Does it make sense? There's no one size fits all solution. For the last 80 years, the answer has been put a diesel engine in it, put a drive shaft in it, good to go. Now we're starting to look at, does pure mechanical make sense? Does full electric make sense? Or maybe a mix of hybrid electric makes sense. There's no one size fits solution. Our design works for some applications, doesn't work for others. I think Wes did a great job of pointing it out. I just wanted to make this video to point out some of the application where it does make sense. We're not after the highway market, we're after the heavy vocational market, and we're after the retrofit market because I believe the economics of retrofitting something you already have makes a lot more sense than just buying something new.
As an official disclaimer, that Edison Motors is not a scam. They're not trying to defraud or deceive anyone. I don't know where that idea might have come from. So, for the record, not a scam.
Thanks. Really appreciate that one. We've got a few people that
look at these smiling faces, as if we would scam anybody.
I'm not 100% on Theron here, we'll be honest.
I'm a little shady, but I'm good.
Should we talk about efficiencies of hybrid? Because that is a great debate that is well worth having. And I think you make some fantastic points in your video.
Yeah, and we talked earlier, it just depends so much on the application that it's really going to be very hard to pin down who gets what benefit.
It's so hard. It's why we've been, even on our website, 5% fuel mile, 5% savings maybe, to 95 to 100%. The range is all over the place. There's no EPGE equivalent you can give for a logging truck. They specifically do not rate vocational trucks for that application. Now, I agree with you 100% with that study that you looked at. It's one of the things we actually looked at before even starting Edison on that studies on highway trucks. I think one of the big benefits of the hybrid electric train and that drivetrain is in that smooth, even power curve. Because with an 18-speed transmission, you let your clutch out, you're at the bottom end of the RPM, you're low power, and then you throttle in, you get a little bit of turbo boost, and then you're immediately on to the next gear. You lose your boost, you're back into neutral for a second, your truck is temporarily slowing down, you're into the next gear, you throttle back in, you wait for the turbo boost, you just hit peak RPM, and then you throttle back out into it. It's an incredibly inefficient use when starting out. However, once you're at speed, that's when the mechanical drive line can really come into effect, because you're not transferring the mechanical energy to electrical, back to mechanical. You're keeping it as mechanical. So at that point, once you're cruising down the highway, it can almost be a wash between the inefficiencies of going through the transmission, the gearing, the U-joints into the rear ends can be about equivalent to what the transfer of electricity going forward. So if you're just running down the highway, I don't think this makes nearly as much sense. And that's what that article was saying for our long haul trucks.
Yeah. I field a lot of the emails at Edison, and people ask us to build them OTR trucks all the time. They want to sign up, and we straight up tell them, don't do it. It's not worth it. You're not going to have the payback, which for the same reasons that your study cited. So we absolutely agree with you. And we tell our own people who contact us, don't do that.
That's why we shared your video on our social media, because I think you made some great points. We put it out on our Facebook. We shared your thing, and you're like, he makes some really good points. But it's about...
So you guys are basically a victim of your own success, right? Because the main use case for semi trucks is over the road, and those guys are desperate to save fuel. That's their biggest expense. And anything that they can find to accomplish that goal, they're going to go after it. And that's Edison Motors, you know, they're looking for something that maybe just isn't there.
Yeah, and it's hard. Like, you did a fantastic job breaking down the engineering of it. How do you view it though, say on a garbage truck then? I would love to know your opinion on a garbage truck that's stop and go, house to house to house.
Yeah, I can definitely see how your system can benefit an application like that. Again, I mean, it's going to be so tricky to pin down how much that benefit is going to be. And it might be where, you know, let's say you're in New York City or somewhere, you know, there are circumstances for those guys that are different than out here where I'm at in the country driving a garbage truck. You know, it's not an apples to oranges comparison. It's so hard to pin down. I can see it, but I don't know exactly what it's going to be.
Yeah, that's the hard part, is that every time we do it, and we've got some models that Eric has made with the University of Oregon, and it has to get so complex where you have to add slope terrain. Like, they had to lay maps over like Google Earth that tracks the topographical features of up and down, and based on like 30%, 40% regen efficiency of captured power, mixed with the load, with the rolling resistance of the load. What are you packing? What's your coefficient of drag? Like, it had to get so complicated, and every single haul totally changes based on what you're hauling, what road you're on, like what configuration your truck is. And it is so hard that I don't know how to get it. I don't know how to explain it, because the last thing we want to do is try and lead people down the wrong decisions by making promises that don't apply to everybody, and have somebody trying to sign up for one of our trucks if it really doesn't make sense for them. So how do we explain that?
So that's where I come in, because I've I get motivated by lots of people who say you can't do that. And as much as I appreciate engineers and mathematicians and people that are a lot smarter than me, sometimes you just got to jump in with both feet and see what happens and go for the best. So even though we're taking pre-orders, it's a small amount to help finance this prototype stage. And the Edison, if you guys don't know who I am, I'm DeBoss Garage. I'm a licensed mechanic in the heavy equipment. I have a background in construction, and then I just started a YouTube channel. We just started swapping anything into everything. One of our builds was a 4-wheel drive quad turbo LS swapped Audi race car, and I went to a pile of engineers and said, will these two turbos work? And it was a two-stage turbo off a 4.6 diesel. And I wrote to every YouTube channel that I could that was smart on turbos and turbo graphs and all of this, and nobody came back to me and said, no, that's going to work or that's not going to work. We threw all these used parts in the trunk of a Tahoe. We went to an engine shop, very prestigious shop. Everything was spotless. We've got this junkyard 4.8 LS. We've got 2 used turbos at a scrapyard that we just kind of MIG welded on the exhaust. And the guy was pissed. The guy was absolutely mad that we did this in his shop. And he was in the other room making fun of us the entire time, going, these yahoos, I don't know why I'm doing this. We filmed this. And then and as soon as we started making pulls, he said, there's a wastegate between the 2 turbos. So a K17 and a K27, 2 turbos. And he said, you need to disconnect those turbos. I can see that you are not going to be able to flow enough air through those turbos to make that engine work. So we disconnected the turbos. We did about 10 pulls, and we made about the same power that he could make with 1 turbo. And he said, I knew it. See, you guys wasted all my time and my shop, and you made a mess, and I could do all of that with 1 turbo. And I said, oh, whoa. Like, can we do a couple more pulls? Can we just hook up those wastegates again and try it again? He goes, fine, whatever, but you're paying for it. Like, yeah, that's why we're here. We hooked up the wastegates and we pinned his dyno. He went to go load it, and our engine flew past his dyno. We had to pull back. And he goes, huh. And he's sitting there, he's looking at the numbers, and then we did it again, and he goes, wow, I take it all back. He goes, I did not give you guys any credit. I build engines my entire life, and I would charge 28, 30 grand to build an engine that puts out the numbers that you do. You just did with a bunch of used junkyard parts. And sometimes we just need to build something. So we can go back and forth, and to all your credit, we need to go in educated and make sure that we know what we're doing. But at the end of the day, we've got a few more issues to deal with Topsy, and we can do these actual pulls and take it up the mountain and do the job that it's supposed to do. And like you said, Wes, it's not for everybody. It's not going to be for everybody. But how many millions of semis are there in North America, guys? You guys know that number?
5 million.
5 million. We don't need to convert 5 million trucks. We need to have these specific applications that will work for the right customers. And our whole thing is, let's try and do it on the internet. We're not big companies. We don't have billions of dollars of budgets to be able to do this, but we do have good work ethic. We've got a good idea. We've got the talent behind us to actually build a truck and then try it out. So next step is, yes, we can, and we're talking with some of the numbers with the Edison boys, kind of between you releasing the video and us recording this, and they've done their homework, but at the end of the day, it's taking the truck up into the mountain and take it back down again and make sure that it works. And that being said, it's a prototype. It's going to break. It's going to run into issues. And the weird thing is that we are actually documenting that and taking everybody along for the ride. We don't want to hide anything, and we don't want to mislead anybody. And in doing so, we're going to look really good on some videos, and we're going to look really bad in some other videos. So.
Like the one that's coming out this week of us breaking our BMS, picking up a wire wrong.
Yeah. Also, that's one of the tricky things, though, with EVs, right? Is that people are so used to being overhyped on both sides of the issue that I think they're just they don't know what to do when there's actual people telling the actual truth. They're used to Elon Musk telling them they're going to have full self-driving trucks that cost $45,000 and have a 500-mile range. And on the other side, they're hearing people tell them that EVs are never going to happen. They're not practical. It's a pipe dream. So it's a tough path to navigate.
And then there's Edison Motors, like, why we shared your video, be like, yeah, it doesn't make sense in some places. Makes sense here. Like, I don't know. We'll find this out. We'll share what we learn as we do it.
We're pretty confusing guys too, because we're actual truckers. Like, we were loggers and that. Like, I have an LBZ pickup out there that rolls coal, and we're making electric trucks. So we're like not the tech guys doing it. We're the actual truck guys doing it. So that's really confusing to a lot of people also. And it's funny when people are like, no, and we just get the anti-EV guys coming. We're like, guys, we're kind of on your side. We just want to make a really cool truck. And then they're like, no, EVs never work. I'm like, well, it's pretty cool though. And it's right, that depends on the application.
And actually, speaking of applications, there's some cool things that I'd like to highlight beyond the video. Was where we've had some customers reach out to us, and they weren't even thinking in fuel mileage savings when it came to the trucks. An example was for a concrete mixer. We had a concrete company reach out, and they're interested in doing a truck. Now, one of the issues is that they want to do a pour 24 hours a day. They don't want to shut down mid-pour, but a lot of cities have noise bylaws where you can't run an engine after 10 p.m. till 6 a.m. No diesel engines, where they can get around their noise permits by shutting off the generator when they hit the residential zone. They may have an hour at a smaller battery pack, maybe an hour of driving range, but they got to go in 15 minutes into the residential area, 15 minutes to unload, 15 minutes back out, and then they fire their generator up. It allows that concrete company to keep their batching plant running 24 hours a day, which means that it's more economically feasible to do a lot of jobs. They don't have to shut the truck down. And we've had a lot of customers that reach out for different applications for that on-site quiet thing. So there's definitely like a niche in those things where what's the economic cost of shutting down an entire job site because of a noise bylaw permit, that we're like, man, that didn't even think of that before we started this. So it's quite interesting.
There's a lot of the way the world's going now too. There's a lot of companies, especially as they're mandating you have a certain amount of electric trucks, and they'll give the bid to the guy who's got 2 electric trucks on his fleet to do the same job as where the guy with none could have done it, but now he doesn't. So it helps you out that way too, especially in like where there's no chargers. How would you make that work? This is actually a way to make it work.
I was thinking about another application too that I never even considered. Police cars and ambulances and even fire trucks, thousands and thousands of idle hours. We used to see Crown Vics, they would have 20,000 hours on them with 200,000 miles. And if you have battery, all you really need to do is run the heating and HVAC and power some electronics inside the car. If they need to pull out and catch a speeder or whatever, the electric car is always on. So that would be a huge win. I remember, we see fire trucks that all they've ever done is idle. And a lot of times the engines don't even last, 10,000 miles because it's all idle hours. They basically just destroy themselves because they never get run. But if you have a battery, that's not an issue anymore.
Yes, that is exactly what you meant when you said that video. They're like, where do you find cars where the driveline is all worn out, but the body's in good shape? Exactly. Like, you know how many trucks in the oil and gas industry that guys just leave their pickups running 12 hours a day, 14 hours a day on site idling? That is perfect. Just exactly what you said.
Yeah, I never even thought about that.
I wanted to touch on the cost as well. Like, we tried to nail down some numbers on how much this costs, but going in when I spoke to Chace and the team about like how much is this going to cost, it really is impossible for us to nail down a number, because they mentioned when they started Topsy that certain parts have gotten more expensive and other parts have gotten way cheaper. So the batteries ended up being way cheaper now. You guys said? We went
down from $400 to about $200 Canadian. Like, that's in just 2 years. The price of the battery has halved. but other parts have gotten needlessly expensive. Like, so I don't know where it's at exactly, but it's fun.
And it also comes down to like how many parts are we buying at once. The more we buy, the cheaper it gets. And to go in again, we need an educated guess. And your guess is as good as anybody else's. You're probably right on. We're figuring somewhere around 50 grand for a pickup truck swap, but we can't say it's going to be more or less until we actually do it. Basically, 2 weeks before we put an order in for all of the components, because things are changing so rapidly that, but that can't stop us from trying to come up with a prototype and see if it works in the first place, right? The first thing we need to do is get a running, working pickup truck and see, does it work in a pickup truck? Does it work in a semi truck? And I came in to join the club a little bit later, but I figure as long as the semi works, then it's some smaller numbers making a pickup truck work. But there's so much to think about when, like, it's not just the efficiency of all this. There's all the stuff that people don't realize behind the scenes too. Legal issues, like you mentioned, with safety. What happens if we get into accidents? What happens if the airbags don't deploy? What if the ABS doesn't come on? So there's all lawyers' fees in the back that needs to be sorted. So this isn't just a thing that we're gonna jump in and go blindly and promise everything. There could be a lawyer at the end of the day that says, no, boys, like, you can't do this. And we're gonna figure out a way that, yeah, we can go around it and we're gonna make this work. But it is super scary. If you pencil it all out, it doesn't make any sense. But at the same time, making a working prototype is the only way to know for sure. And that's what we're doing, right?
Well, so that's another problem too with EVs, right? Is that people aren't used to, well, we've never been exposed to what EVs actually cost, because they've always been subsidized by the government or subsidized by companies who are willing to sell them at a loss to get market share. Or now there's currently a price war between Tesla and multiple Chinese companies, trying to get market share in Asia. So who knows what it actually costs to build an EV?
That's right.
Yeah, and that's exactly why we didn't want to. We didn't want to put out I hated what like Tesla did with a Cybertruck, where they're like, yeah, it's going to cost around 50,000. And then they came out with a price that was 100,000. You're like, whoa, that wasn't even close. We're just like, hey, probably about a third to half the cost of a new truck, depending on how fancy your truck is or whatever. I don't know how else to justify that.
Right. Well, that was something that was interesting too when we talked earlier, is that I'm so conditioned by where I live that there are no vehicles here that are worth putting $50,000 or $100,000 into. They rust into a pile and we crush them up and make new ones. But that's not the case everywhere. And they're, you guys talking about specialty vehicles in the oil field that are costing $1 million. And, to put $100,000 into $1 million truck is a whole different equation than putting $100,000 into a $5,000 truck.
Exactly. Like, it doesn't make sense. Like, you can buy a Freightliner Cascadia highway truck, brand new, for about $150,000. Doesn't really make sense to take a 5-10-year-old Cascadia that's worth 10 grand and put 100 grand into it. But if you're going to buy a brand new logging truck rigged up, is about 500,000. A brand new 40-ton crane truck can run you upwards of $1 to $1.5 million. If you've got a $1.5 million truck, spending $100,000 to make it brand new again is absolutely justifiable. On the Freightliner Cascadia, that's pretty stupid. I don't know what else to say.
Right.
So we had somebody reach out to us on the pickup truck side and say, I've got a 2017 truck that you can just have. It's a crew cab, 4-wheel drive, 1-ton GMC with diesel. And I called them up, like, are you serious? Like, because to you and me in the Rust Belt is like, that's like gold. Like, what are you doing? This is a $20,000 truck. He calls up, he's from Arkansas, and he said, we've got about 25 of these trucks, and we have or maybe even more, but he goes all over North America for his business. And in that 4 or 5 year range, they put 350, 400,000 miles on it. And he says the trucks are just done. He goes, but like I look at the body, and the body's just perfect. You got rocker panels, you got paint, you got a crack dash, and you got a wore out truck that he says, I can't sell these things. I can barely give them away for $3,000 because basically we park them when something goes wrong, whether it be a transmission, an engine, or a differential. And we have to fix that to be able to sell the truck. He goes, but even if we fix the diff, it's still a ticking time bomb. I don't want to send my guys the other side of the country and have to pay for them to fly home or whatever it is, wait for a repair. So he goes, we just go out and buy another truck. But that's another, again, that's another $100,000 truck they are now, right? So I asked him, I was like, what's the condition of the trucks? He goes, oh, they're mint, like they're absolutely perfect. So he goes, we're going to send you one next time we're in the area. We'll float one to you because he's got semis as well. And he says, I just want to see you work on a truck and see what you can do to convert this, because I would be interested in that second life on my fleet. Right? They already have the service body on it. They already have all their tools and everything. You ever tip over a toolbox and spend 8 hours putting your sockets and your wrenches back? It's one of those things. It's like, it's your truck, it's your baby, you know where everything is. And to just give that to a program like this, where it's like, okay, you know what, we're gonna put a new cushion in the driver's seat, we're gonna reupholster the driver's seat, give it a good detail, replace the cracked windshield, and then at the same time put the engine, transmission, the engine, the generator, the batteries, and the axles in there, and try to get another 300,000-400,000 miles out of this thing and see what it does. But we'll definitely be driving our pickups across the countries doing that first to make sure that makes sense. So we're not thinking about we're thinking ahead, trying to do the mass production side of it, which is super complicated. At the same time, it's like, maybe that's not the right customer again, because you drive for 10 hours straight and you're not really saving that much. But I had a buddy call me up last week, a 2017 or 2018 Cummins, and he goes, the turbo went and we got a quote for 10 grand. He's like, is that accurate? And I started pricing out the turbos, and yeah, absolutely, it's accurate. It's about $5,000 US plus the time and the energy, or the taxes, shipping, brokerage to get it to Canada, plus the labor to put it in. You're about 10 grand, and it's just a turbo. That's not the engine, it's not the transmission, it's nothing else. So when you've got a truck and you see those repair bills coming, but you still want to keep that truck around, it might not make sense. It doesn't make sense to take a perfect. There's a guy that says, take my 2024 Ford and put this kit in there. I'm like, no, there's nothing wrong with your truck. Drive your truck. But when you see a repair bill for 10, 15 grand or whatever, then it's not a $50,000 swap. Now you're into it for 35 grand, because you still have a used driveline when you're making a repair for $5, $10, $15,000 on your truck, right? So there's again, it's that larger scope where on pencil it doesn't make sense, but then in reality you're like, oh crap, you know what? I got to fix my truck for 10, 15 grand, and I want to get a generator for my house. He's like, well, there's another 10 grand. Now it's only a $25,000 swap, because your truck is now a generator that you can plug into your house. So the electricity goes out and you're in the dark. Well, fire up your truck and park it outside. It'll kick on when the batteries are low. Now your house is lit. Your meat's still frozen, your ice cream's still frozen, and you're nice and comfy warm when everybody else is freezing to death. So it's one of those things that we gotta move forward and try it. And if it doesn't work, we'll be honest and say, you know what, it was a good idea. Maybe the technology's not quite there yet, but we're going to try and do it anyway.
Well, there's another aspect to that, and maybe that's more, I guess it's for all of you guys, and it's even harder to quantify, which is that you're showing people how to do this stuff with EVs. And from my experience, when you say anything about electrical, people just turn their brains off. Like it's a mystery that they'll never understand. But it's not that hard. You know, we're doing it already. We know how to make cars. We know how to make electric motors. Is it that hard? I don't know.
No, and that's one of the things that like what I'm trying to show people is that a lot of these big OEMs, they know people just hear electric and they don't want to hear anymore. And then all of a sudden, well, now you can't even open the hood on a brand new Mercedes. If the software updates installs wrong, you can't drive your truck. You can't service it. You can't look at it. Don't even think about doing a brake job on a new Lightning. It'll shut you down. And we're trying to say, like, it's not. Electric is not complicated. Electrics have been around since the 1930s. As far as like diesel electric locomotives go, I know our truck's a little bit different than that. That was a fair point. It's theoretically similar, but different. But it's not new. It's not impossible to work on. You can make it simple. It's why I like the fact that me and DeBoss and Rich and the other guys, the shops that want to come on board, want to try and get these kits out, because I'm so tired of the way that they're using EVs as an excuse to push planned obsolescence. They're using EVs as a way to fight right to repair. I want to make a simple kit, design something that the average person can work on that doesn't put the small shops out of business. Is it a lofty goal? Yes. But I think somebody needs to do it, or else they're just going to keep shoveling down vehicles that nobody can work on, nobody can service, and nobody will own it or fix anything.
Oh yeah, it'll be like a throwaway car. It'll be like, oh, it doesn't work anymore. Okay, throw it out.
Whether we like it or not, and none of us do, EV mandates are coming. Like, they're coming. So people can sit here and fight and be like, no. Well, one day it's going to be absolutely yes, and there's nothing you can do about it. So if there's not someone like doing a thing like we are, no one's going to be able to work on your truck. So people should kind of support this kind of innovation of letting you do it, letting the mom and pops do it, and taking away the planned obsolescence. Otherwise, in 10, 15 years, all you will be able to do is be forced to buy a vehicle with planned obsolescence.
Yeah, what California already said, you can't own a truck over a certain weight if it's over 15 years old. Unless you completely gut it and rechange it out and retrofit it, you can't own it. And like that's BS. But
California, they must have a lot of emissions because they're not thinking straight anymore. They're smelling some weird stuff because they outlawed internal combustion generators. I mean, if you're working, if your electricity's like, if you're working at somebody's house, you don't voluntarily have a generator running to run whatever tools you need. That is in an emergency. When a hurricane goes through, or a tsunami goes through, or an earthquake comes through, and these are the people that are making the decisions. It doesn't make any sense whatsoever. I really hope that people do wake up a little bit and realize who they're voting for and who's making some of their decisions. But anyway, that's besides a whole other thing. Wes, I want to ask you: Have you driven EVs? Have you had much experience with them?
Not that much. I've driven a few. I have not worked on one in any serious capacity, but I'm curious about it. I mean, I'm very interested in EVs from a technological standpoint and maybe from an economic standpoint. I'm not interested in the politics, but it's impossible to separate the two.
Yeah,
but
yeah, it really is.
I mean, it's coming, and I want to be prepared for it. There's no reason not to be.
Yeah. So
you really got to drive an EV, because once you hit the throttle, you are launching that thing. When the torque is definitely there, and when we've done Topsy and we pulled some weight with it, that thing is gone. Like Carl, our 1962, the first truck we did up, you hit the throttle and it's gone. Like, I'm just twisting drive shafts. Literally, I sheared U-joints in the drive line just because of the electric torque when you launch that thing, that we had to go to the E-axle. The torque is insane. I don't know how to explain it, but that torque off the line is crazy good.
It's like a roller coaster, right? It's the same concept, right? Yeah. You've ridden Disney World, it's something else.
and
I think I just watched the DeBoss garage video where he said that an electric vehicle takes all the fun out of the driving experience.
It does. so here's the thing though, like, and I stick by that, because again, when you're driving, when you're driving, you go from 0 to the speed limit, and it takes a matter of seconds, and then you need to get to where you're going, and you you can't rip on it every single time. You're gonna like roasting tires. I've seen people who've tuned their trucks and they're like 3-4 months later and their back tires are gone, and they're like, I didn't smoke the tires, I didn't do burnouts, but all my rubber's gone. I said, I know, because when you take off and you got a heavy foot, all that power is going through that rubber, and even though you're not burning it, it's still taking that rubber off. So when you're driving a car, you can only do that so many times, and it does wear off. Like, okay, I can go to 0, I can push myself into the seat, and that's fine, but you understand how expensive that is doing that at the same time. In a transport truck, I think it makes a lot more sense, because that's what you're doing all the time. In a transport truck, I think you want to get up to speed more than you do the thrill of getting from 0 to 80. You want to get to where you're going, and the longest delay is that getting back up to speed again. And the first time I met these guys was when they pulled the tank at the scrapyard, and they let me drive it and pull it away. And I've got that 87 K100 cab over with the 3406B in it, 13 speed. And I love the shifting, I love the smoke, I love all that. But when I stepped on the throttle on Topsy and it just moved it, I had to look behind me to make sure that the tank was still there, because it's just so instant and it's so addictive. It's like, wow, like I was speechless, and that's what got me interested in the first place. Driving home again, it's just you got 10 cars behind you because it was a bunch of small roads, right? And they're all pissed off and they're impressed with the tank at the same time. It's like, I'm sorry, I know it's Sunday, you want to go home, but like they said, once you've driven the EV, once you understand that torque, it is really addictive.
Well, and it eliminates the frustration that I think every trucker feels, because all the green lights are timed for car acceleration, and you start off at a green light, and by the time you slowly go through every single gear, you get the next red light, and then you start in the basement. If you can get up and get on it, you can make the next green, and then you continue with the flow of traffic, and you'll hit all the green lights that are timed. In a semi-truck going through every gear, you hit every single red light because you can't make the timing. That is a big difference for a city driver.
Well, that's maybe another issue too, which is driver fatigue. I had a rollback truck with this, it had straight pipes and 8 low transmission, and the exhaust was about that far above the wind, the passenger window, and it's fun for about 30 minutes, and then it's just annoying. And at the end of a 10-hour day, the last thing you want to see is the hill or a stop sign, like, oh, I got to shift another gear. I just want to go home. And with an EV, there's a lot less to think about.
Yeah,
Absolutely. And more importantly, too, what's cool about Edison is it's built by guys who really like the vehicle. Like, these guys are truck drivers. Being out in the field at the bush for a while in a pickup truck too. It's kind of neat to think that we've built something like the pickup truck kit around what we had before was a trucking company, right? Like, we've had service trucks in the past, firing up and idling that compressor all day long for no reason. It just made such sense to us, more than just the fuel savings, but the applications of this vehicle are infinite. And, that's what we want to leverage on, right? It's cool to see that there is potential for fuel savings too.
Do we want to show Wes the model?
Yeah, sure.
Do you want us to share the model with you, what we got?
We talked about it a little bit before, so I'll just share my screen here. That's okay, guys.
We'll send it to you after here too, so you can review it a little bit more.
Yeah, you can make some modifications.
So Wes on his video had a model that was pretty good.
You're on payroll now too, Wes.
Oh.
Like everybody at Edison, we just now put you to work immediately. So this is one we did for a customer. They're hauling iron ore in 24-hour shifts on the Hope Princeton Highway from Princeton down to the coast. For those not aware of it, it is straight. You're up and down. It's 100 kilometers, but it'll take you about 2.5 hours in the loaded truck because you're constantly up, you're constantly down. It's a slog. It is a pull. Mm-hmm. You're up to 15% grades, slow to 20-mile-an-hour corners at the bottom of a 20% grade. It sucks. So if we kind of work through a little bit, why don't you lead us through here, Eric?
Yeah, I mean, and you know, Chace kind of jumped a little too quickly into it, right? Like there's a matrix on essentially what you anticipate your loads to be during a day, right? On an hourly basis, because I could do it by a minute, but the model, it's already 80,000 cells. So like if I multiply it by minutes, it just gets worse. But there's also a really important column, which is the regen side. If you want to get fancy too, you could even assume that it's charging throughout the day, right? So you can do that as well. We even have a potentially, if you want to have a solar trailer behind you, you know, it could produce a little bit of power. But this is the cool part of the model here. And this really gets down to brass tacks, how many kilowatts you're consuming, right? So if you're pulling 65,000 kgs, you're driving at an average speed of 110 kilometers an hour. And you're doing it at 2% grade. This is what we anticipate based on all of our factors. And at that grade, how many kilowatts you're consuming. And, you know, just trying to showcase that, yeah, we were talking about 200 kilowatts there. Yeah, that is 200 kilowatts. But that's the draw, right? If you do need to stop a few times there, you're getting some regen. And my regen matrix is typically around 10 to 20%. In this case, it's 13%. What's neat too about this graph is it just kind of shows you, based on those figures, what that kilowatt looks like if you're changing your speed. So if you need to pass somebody, you're going 140, you could really see that spike in kilowatt consumption, right? You know, so it was a powerful thing to add yesterday, just to kind of be able to showcase to people what that range would look like when you're pulling weight. But it is quite variable. But the whole idea is when you're passing somebody, you're not doing it for long.
Yeah, and if we look at fuel savings, I think that's one of the ones. So at that 200 kilowatt, because I think that's what you said in your video, and that's about what we found. And we only assumed 13% efficiency on the regen, so we really assumed it low there. But you can see before, this is what they were currently burning per day. That's from the customer right there.
And that's in Canadian, right?
And that, liters,
yeah.
And basically, the diesel power cost with Edison, it shows you we're burning 936 liters. So we go from 1,200 down to 900 on this particular highway haul, which running double shifts 5 days a week. The diesel savings at $2 a liter for 300 days a year, basically during the weekdays, worked out to $276,000. And that's the cost of a brand new truck, top end, as fancy as we could spec it.
Yeah.
And that is a 1.63. Now, obviously, if you're running one shift, double that, that's about a 4-year payback. But if you consider the fact that the diesel equivalent on this truck is $300,000, you're really spending about an extra $150,000 more. And you nailed it with your state of charge, Wes. You can see here on the model, at 6 a.m., your battery's dead. So from 5 a.m., you basically get to 6:20. You get about an hour of driving on this haul. It's heavy. And then while running the generator, it goes all the way up till what? 10:30, 6:30 to 10:30. So it does take 4 hours to recharge, burns it back down in an hour.
Yeah. And then it cycles through that. Yeah. Yeah, it's actually in the model there, right? So as I put down there, operating hours per fully charged battery based on those figures. Obviously, this changes sporadically during the day, but yeah.
And you can even, can I do this or does that?
Yeah, for sure.
I'm so bad at Eric gets mad at me every time I do this. But if you have an average of 10% grade, you can see that consumption, it should have changed.
It did, yeah. It was at 190.
Oh, okay. Yeah. This didn't change very much.
No, you have to manually put all that stuff in.
Okay.
This is kind of a snapshot in time.
Don't hit save.
Yeah.
Did I hit the wrong button?
No, that's good.
Okay.
I think it's
Sorry.
We'll see the record. So that's a big significant difference than the potentially 19, 20-year payback.
Yeah.
If you were doing an OTR application, which we don't do that.
And that's in the mountains with super heavy weight, obviously, but what do you think of those numbers? I'd love to hear your feedback on them a little bit. Of course, I'll send it to you later, but.
No, that's what I wanted to see. And that's kind of squares with what I was thinking too. And, that's pretty obvious in that application. It's a slam dunk. I mean, it just is. It won't be that way for every application, but in that niche, that's the target.
Yeah. And
Yeah.
that's at 13%. Where you get logging where you can get up to 60%, 50 to 60%, it really drives home those economics.
What's up? Maybe you guys don't know, but where I live, there's a fair amount of logging, and margins are super thin. Like, it's very difficult to make money logging. Is it the same for you guys?
No, loggers. Well, right now it's been a little bit different, but normally loggers make good money out here. But our weights are a lot higher, and how do you best say it? Just
Well, the loggers are company drivers down in the US too, right?
but even as company drivers, though, it's
Okay.
like as a company driver, you can make about $50 to $70 an hour with a good company, 35, 45 with a bad company, depending on where you're at. Like it's good money, but you're in it's a very high skilled job because you don't always survive. It's incredibly dangerous.
Danger pay.
There's definitely some danger pay depending on where you're hauling. And it's one of those things where the trucks have to be built. When you're packing 180,000 pounds, 160,000 pounds of logs up a 30% grade with trucks that are spec'd, it's a different ball game entirely than when you're light down in the States. Honestly, the States does not do themselves any favors by not having heavy weights.
Yeah, you guys are like 80,000 pounds. We're pulling easily, like our average load is gross is 135,000, 140,000. And
So
then
I don't know if logging counts as agriculture, but like farmers are allowed to go 10% over in certain times of the year, so they can go 88,000. But no, it's a big problem. I mean, and there's complicated political reasons why it's probably not going to change. But yeah, from an efficiency standpoint, it's not helping us at all.
No, it's not. And
I
like,
mean, from a truck driver standpoint, I guess it helps you because there's more guys required to drive trucks because we need more trucks to haul the same amount of freight. But from an owner's perspective,
I would argue actually the other way is that you find that drivers' wages are a lot higher in Canada for log truck drivers because you can pack more weight. And the more weight, the more economically feasible it is to pay the driver more because the truck is making a higher profit. Because logging in the States is very similar to here. You get paid for the amount of weight you bring into the mill. If you can bring in more weight, you get paid more. As the truck gets paid more, the wages tend to go up. But then again, you have less people. I guess the question is, do you want more people driving truck or do you want it to be a more competitive job? Like it's a more competitive job here because it pays very well. It's harder to get into. They require a little bit more skilled, whereas you find in other areas like Eastern Canada, where it's a lot more flat land, it's a lot easier to get into. The wages are a lot lower because it's more of an entry. So that's a hard one to justify. I don't know. I'm on the fence on that one.
we should kind of add that you guys are still probably way better off because we, at the end of the day, pay probably over 50% tax. So
well, there is that.
yeah,
I don't know. I don't know of another developed country that has kind of the strict weight limits that we have. And I don't know why, other than politics, why it is that way. Mexico, I think, is about the same as us. They don't have Super Bs or anything down there. And there are states in the US where it's totally fine. Michigan, for example, you can put as many axles under that truck as you want. But where I'm at in Illinois, it's not going to happen.
Yeah, and I don't know. You guys might be better off too because your fuel is way cheaper. I'll be honest. A lot of these economics that we put out are being in Canada, where I think if you break it down, we did the math, it's like $8 a gallon. When you're paying $8 a gallon, suddenly any bit of fuel savings sure makes that payback period a little better.
when we were in Texas, we realized maybe when we filled up the vehicle, we're like, maybe our fuel argument doesn't quite go as far down there because, man, I wish. Like,
Yeah, so in my calculation, that was the number one factor. I mean, if the truck can get, if you have a truck that gets 3 miles per gallon, it's half the payback of a truck that gets 6 or 7 miles per gallon, as you would expect.
Yeah, and you definitely do not get good fuel mileage pulling weight here.
No. Especially when you got to use energy to slow yourself down. Like as soon as you start doing that, it's just laughable. It's just like, what? Like you got to use energy to slow down? What? Hybrids are way better for that.
Sure.
Did you touch on the weight aspect of it as well, Wes? I think we have some weight issues that we got to figure out with the pickup truck side, but with the semi, Topsy didn't weigh in a whole lot less than a factory diesel truck, and that does come into effect a little bit if they are mandating that you have an electric truck. I think the Tesla semi weighs an extra 8,000 pounds or so because the batteries are so heavy, but because they've got smaller batteries, they don't have that issue. So again, it comes down to, well, now for every 3 loads that a normal transport truck can do, an electric semi has to make 4 trips because they can't carry all that extra weight because of the battery. So if we're moving forward, going that, we need to have EVs in a certain aspect of the transportation industry, then hybrids still make sense, even if nothing else, because you can run on EV and still meet whatever little mandates that way, but you're not taken away from your payload because your truck doesn't end up weighing a whole lot more than a full EV vehicle would. Now with the pickup truck side, we still got to figure all that out with whatever engine we're going to use to match the emissions, which is why we're going with an older pickup truck and using the Cummins in there, because the Cummins is cheaper and weighs less than the Cat that we were thinking about using. But we're going to be close to our payload because these trucks are so big now, and we've got so many electronics and so many extras on there that you can't throw a camper on the back anymore and whatever, because you've only got 500 pounds of payload left before you max out. So that's something to definitely consider while we're working. But again, we don't know those numbers until we can actually prove that it works and then go from there. Maybe by the time that happens, we've got a better battery system or energy storage system or a much lighter engine that's able to produce the same amount of power that we need for the generator. But first things first, it's just getting one down the road and seeing, if it works, let's keep going. If not, then we'll have to deal with that or change something or figure that out then.
Well, so that's not an Edison specific problem though, right? Because it affects all EVs. And I've heard recently that our state DOT now is changing regulations for crash barriers and guardrails because cars are so much heavier. These electric cars are so much heavier. Insurance rates are going up because when they crash, they do a whole lot more damage. It's also more wear and tear on tires and on the roads. So, a lot of factors that, things you don't think about initially.
Yeah, that's right.
At least that doesn't apply to the semi trucks because you're loaded to max weight no matter what, whether it's batteries or logs making the weight, still loaded. Although
one thing we did recently, like with Cybertruck coming out, is that towing is the Achilles heel for EVs, right? And it seems especially to do with aerodynamics, because the main way they're getting efficiency out of EVs is better aerodynamics. But you hook a big brick of a trailer to the back of it, and suddenly that goes all out the door. So,
yeah, that's why when we did the math on our model there, you see that the Tesla semi says like 100 kilowatts per 100 kilometers, like a kilowatt per kilometer. We said 200 because that is completely ridiculous. That 100, if you're super slipstreamed in the truck and you're super slipstreamed down the side of a trailer, you know what? It doesn't make a difference if you got a D8 Cat on the back. Like, right. Double it. Just immediately double it at the minimum.
Well, so Tesla seems to be targeting the trucking market where they call it cubed out, basically that the trailer is full before it reaches its maximum weight. And there's a lot of places where that happens. Like a couple times a day, there's a truck that goes past my shop loaded with foam insulation panels. It weighs about 3 tons, and it's a 53-foot flatbed trailer. So in that application, maybe you could get 100 kilowatts per
kilowatt hour, 100 kilometers per kilowatt hour, whatever.
You just need to hire a chip company to be your advertising for you.
Right.
It was very much the same.
It's yeah, I see why they're going for that, because honestly, if you look at our if you were to assume like those were mine trailers that are relatively slipstream at that 200. Oh, by the way, since we've done that, now the generator does 350 kilowatts. That video we did like a year ago, we changed it up. That was done after we built Carl. That video was a year old, and we've learned a lot through the testing process in Carl. Now we're putting out 350
for a brief moment in time. Yeah, but like, you could probably do it for like 10 minutes, right? But the idea is you have a lot of power if you want it.
You mentioned a couple other things in your video about the complexity of the newer trucks, all the new CAN buses, making airbags work, making ABS work, and things like that. And we are 100% aware of that as well. Trying to think outside the box yet. These axles that aren't that we're getting made don't exist yet, and it's hard to explain to the rest of the world what is normal in North America. We, like the rest of the world, has 6-bolt rims and drum brakes. It's just that's because everything is the same. That way, the drum brakes are easier to reline. So when you go into poor countries, it's easier to have a universal kind of drum that anybody can put a new lining on it and put back on the road type of thing. So with the complexities of the new trucks, we're looking into even being able to put the hubs from the vehicles onto the axles, the electric axles. That way we still have the same ABS sensors, we still have the same brakes, so we're not changing the brakes any safety wise that way, or we're not putting a more inefficient thing on there. If that works, that's great, it's fantastic. If it doesn't, we'll have to figure something else out. We might have to make our own and get them all tested and stuff like that. And that entire process, when everybody's watching, takes a very long time. But we're trying to think of all the different ways to make these kits as seamless as possible. And when I say seamless, it's not seamless at all. It's like you putting a different engine. It's like all these guys saying, I put an LS on my car, and it's like, well, the last picture was just an LS sitting in the frame rails with no transmission hooked up and no front grill on the vehicle. Where are you now? It's like, oh, it's actually pretty complicated, and it is. But we're up for the challenge, and we're looking forward to making sure that this is done safe and that this is done to the best of our abilities, and then trying to find and hire the people that we need to that have a different skill set than ours, right? So airbags, again, they are their own system, and I don't know if they're tied into the particular CAN buses or not, or if, as far as the vehicles that I've worked on, the airbags have been their own system, their own yellow wires, their own computers powered up, and those airbags are going to go. So, but again, we'll look into that. But that's not a system, like our drive system wouldn't interfere with any of that system. And it's, as far as my understanding, the ABS as well. So if we can incorporate the hubs in that from the original vehicle into the new axles, then we've got a lot of problems solved. And we're just exploring all those different aspects. Now, you're 100% right. There's a lot to think about, but we're trying to think of that and make sure that is still cost effective and safe at the same time.
Well, yeah, there's lots of companies that make kits for cars. Like you look at the Volkswagen, the Porsches, all the classic car EV retrofits. I think we're just the first one to do it for pickups.
Yeah, well, so you know, Rich, as well as I do, that they've made vehicles hostile to repair, which inevitably makes them hostile for modification. And yeah, I mean, they're actively trying to prevent you from being able to figure out those systems to reverse engineer them and do what you want to do. But, so I don't know where that's headed.
But at the same time, we live in an awesome age with a lot of smart people in their garages that are on Reddit and opened up a whole community. And it's like, hey guys, let's do this thing. And as smart as engineers think they are, I think building these vehicles, trying to lock people out. There's the same with John Deere's and that. It's like, hey, you know what? I already know how to do this. Give me a call. Don't tell anybody, but
Right.
this is how you get in, and we've already manipulated, and that's the scary part on the EV side and the new cars. I think Biden's talking about a kill switch on every vehicle too. Like I always said that, like, Elon Musk could have a bad day, stub his toe on his coffee table, and just say, screw everybody today. Every Tesla is not moving. And and that's not good. So there's that, and that's why we're also putting stuff on YouTube and showing what we're doing, because our audience is chiming in saying, hey, I know the canvas on this system, and I've done this. Actually, I've taken this engine and I've put it in something else, and I've already done this, and this is what you need to do, or you need to call this guy or this. So that side of it, we have a much more positive workforce that wants to see us succeed and helps us with that we just need to ask a question, say, hey, you know, we need a company that makes custom ball joints to fit our hub to their axle. Who works for a ball joint company? Who knows where this company is? And generally within a day we have emails saying, hey, I know the person, call this person. Let's see, who knows a lawyer that says, is this even legal? Like oh, my dad's a lawyer. Let me ask him at the kitchen table tonight, and I'll see what he says, type of thing, right? So that we're doing a new thing where we're sharing all of our successes and our failures in real time, pretty much. And I think it's massively advantageous to be able to do that, because when I read all the comments on your video, they're all kind of rooting for you, and they're agreeing with you and saying, yeah, they're like, the hype, I wasn't on this hype, and you know, they keep referring to trains, and trains aren't that efficient. But if you read our comments, it's the polar opposite, because they're rooting for us, right? So it's just that narrative of, like, once they understand that, no, we're not making flying vehicles that solve every issue that's ever been in the automotive industry. We're solving some and creating others, like other problems. But it's just a neat opportunity to try, and nobody's done it before. So you know what? Let's just jump both feet in and see what we can do.
Don't email us for ball joints.
Wait, like a couple more. Wait, I don't know how many emails you guys get a day. It's got to be hundreds, thousands, like just so many emails. We've got to hire staff just to read the emails to see which one's legit and which one's not.
No, that's true. That's literally true.
And so, just for the record, I'm 100% on board with that. You know, building something that's never been built before is worth doing. Absolutely. I'm a little bit more cautious, I guess, and trying to keep people from getting their hopes up too high. You know, like I said, everybody wants that magic bullet, and they're looking for it anywhere they can find it. And when they see something that looks like a magic bullet, you know, they see what they want to see.
That's right.
And we've been very adamant, though, that this is not a magic bullet. This is for vocational trucks in our niches that we've talked about. It's not for everything, and we've told everybody, like, we're not making a highway truck that the range is anywhere. Like, it's a huge difference on that range and what you're going to save on fuel. I don't know, it's hard to explain, but it's
and I fully appreciate that you have to walk a very fine line, because you have to generate some buzz and some hype about your project, because that's how you get it sold. But at the same time, you know, like I said, people see what they want to see, and they see there's a solution for their specific problem in your project, even if it may not be there. So it's really tough to navigate that.
Yeah.
No, and that's where, like, I think your video was, it definitely made the math checked out for the highway application and all that. But when it comes to, I think one of the main issues I had was the series hybrid versus parallel hybrid. things like the Prius, and there's a ton. I think there's like 20 cars on the market that are series hybrid. The best thing we've had is for estimates has been able to extrapolate on the car side that the series hybrid proved itself very efficiently in city driving, and it falls short on highway driving. And we've just tried to bring that out into the vocational side, that yes, heavy city driving, the trucks that are loaded to 100,000 pounds in city driving makes sense. It's like a giant Prius, not make sense. But I think that was the only part of the video that bothered me. I'm like, it makes sense in some vehicles.
You have to be careful with the terminology because the automakers seem to kind of call their vehicle whatever they want to call it. So from my understanding, like the Prius and the Chevy Volt, all those cars, those are parallel hybrids, or sometimes they call them parallel series hybrids. So like the Bolt is the one that I know the best, and it is a series hybrid up to about 100 kilometers an hour. And then after that, it does have a way to connect engine power to the axle because, like you said, once you get the highway speed, you don't have that efficiency anymore.
I think, what car is it? There is a few out there that literally have no connection, but I'm not versed enough in the thing, and I'll admit, might have fallen. It's one of those ones where I'm going off with the manufacturers. I'm not physically climbing under these cars to have a look.
Well, so someone in the comments said there was a BMW model that is a true series hybrid. I don't know. I mean, I live in the middle of a cornfield. There's no EVs or hybrids around here. So I don't have a whole lot of firsthand experience with them. I just go off
what I went to is the Cat. Have you seen those new Cat D8Es or D6Es, the electric Cats? They are a series hybrid where it's just a generator to electric motors to the drive for the Cats. And they're showing about 35-40% fuel mileage.
Mm-hmm. And I can absolutely believe that a series hybrid would be more efficient than a hydrostatic drive or a torque converter in almost any application. I mean, yeah, that's hydraulics is one of the least efficient ways to transmit power. It's great because it's super power dense, but it's not efficient.
Yeah.
Was that Ram Charger not a series hybrid too?
I believe it is, yeah. We don't know that much about it or even when it's coming out, but
no,
yeah, I
we
believe
only
it
have
will be.
they say. And
a nice thing about doing the pickups, well, it depends on how you use your pickup too, but like it would not be the best if you're doing long highway drives, but you could just use it and plug it in at home, use it for your town, and then you don't have the range anxiety if you want to go camping or something that weekend. Like that's a good application for it. Rather than having
something I was trying to maybe get across, and I think I did a poor job of it, is that fuel savings don't necessarily have to mean money savings. Like there's other reasons to do it besides just saving money. And even if you had a vehicle that could run on battery power 90% of the time, and the 10% of the time that it runs on fuel, it gets worse mileage than an equivalent vehicle. So what?
yeah, and I mean, for 90% of people that own pickup trucks, 99%, they use it to drive into town. They drive 20 minutes into town, they go to work, then they drive 20 minutes, 30 minutes back home again. They probably never have to run the generator until they go up to the cabin for the weekend. And it's one of those things where, like, should they buy one electric vehicle just to drive to work on electric, and then just have one vehicle that's gas to go up to the cabin for the weekend? Like, the range extended kind of makes sense there. You just buy one vehicle, and yeah, you might suffer a bit for the highway mileage, or it might just be a total wash for the highway, but you save for all the rest of it. It's like the service truck that spends the majority of its time working on site. It spends an 8-hour day pulling wrenches on a piece of equipment where it's all idle time, and then it drives an hour and a half back home on the highway. Is it really getting as much savings as it's driving home on the highway? No, but it's getting a ton of savings in engine wear and fuel while it's not idling on site.
Right.
I pay a lot of money for great acceleration.
And that's the other thing. That for Midwest, there is probably just going to be a market that just wants the absolute power and performance of pushing themselves back into the seat to lay rubber in an old square body Chevy.
I have never.
That's where Rich is going to come in.
Yeah.
That's his forte.
Yeah.
Never bought a vehicle in my life for fuel mileage. I've never.
I mean, if you put it down on paper, there's nothing about classic car modifications that makes any sense financially. So you're already off in the weeds. You might as well go further.
I get emotionally attached to vehicles, and that's a whole other market too. How many pickup trucks are there in North America? You said like 160 million?
142 million, according to
142 million. I just need 0.001% of that market, and I've got work the rest of my life, right? But my regular cab long box was my first real nice truck, my 05 Silverado. It was the only one I bought that was like 2 years old, and that was my baby. It brought me to work. It brought me to dates with my girlfriend, which is now my wife. My best dog was always riding in the back, and I've put a new body on it. I've put an insane amount of money into a compound turbo P pump, 24 valve, and a stupid paint job. But that's also another thing, is that people have the money, and you know what, it's my baby. I can't let it go. But you know, I'm sick of the 350. I'm sick of the 12 valve. I'm sick of the 6.7 or 6.6, whatever's in there, and it's time for me to get this smile on it again that I used to get 15 years ago or 20 years ago. So yeah, and I just want to say too, when with this pickup truck that we lined up with an emissions facility, very top end at one of the universities close by. They have a dyno and they have a fuel cell that measures the exact amount of fuel that goes down. They can simulate wind resistance and hills and accelerating and decelerating. So we're taking the truck there and its stock form with its 360 that's in there now, the gas. We're just going to do a bunch of driving simulations, just take a bunch of data on that and post the data. And then we're throwing the 2.8 Cummins in front of the manual transmission. We're going to do the exact same tests again. And in that facility, because it's in a controlled environment, we can pull up the drive simulation from the previous test and duplicate that test to 100%. Just got to keep the RPMs in between that line as the dyno goes up and down. And we'll do a 30-minute drive cycle. We'll do hills. We'll do simulated towing, part of that, and then we'll replace the drive line and put the electric kit in there and do the exact same test again. See exactly what that does, and does it make sense? Does it work? Does it do exactly what we hope it does? And if it doesn't, we'll adjust and do that there. So we're doing the best that we can to be open to the public and explain what we are doing. Hopefully it works. Hopefully we've got the backing of our viewers and people that are excited about that, excited about Canadian innovation, and are rooting for us. But at the same time, we do appreciate you looking at it and looking at the numbers and saying, whoa, like, get your heads out of the clouds and make sure that you know, it is what it is. But again, thank you for the opportunity of talking to us and just making sure that, you know what, we're all on the same page. Yeah.
Agreed.
Yeah, I think we needed a voice of reason to bring some of that down.
Is there any questions you have for us, Wes, or anything that?
No, I'm very. I'm looking forward to seeing those results. I think that's going to be really cool to see. And
yeah, I'd love to invite you up here to come take her for a little drive, see how it works, and really go into some of the in-depth part of the engineering that's easier to show off in person, like exactly how our axles, they've got 2-speed rear ends and they switch gears, but in different times, like how Tesla does it, like we do. There's a lot of really, really cool things that mitigate some of those questions you brought up that I'd love to be able to show you, love to be able to let you take her for a drive.
Well, and you know, not to tell you how to run your business or what to do, but showing off those features in a video, you know, that might be a good idea. I'm sure there's people that have the same questions that I do. I didn't know that there were 2 speeds on the axles. I knew they had a neutral position. I didn't know.
Yeah, that's one of the problems when you put out so much content that there's probably hundreds of hours to go through. It's hard to get every feature in every video.
Right.
Anyone watching this now, Wes did make a great video that we've referenced. We are in the process. We do have a video coming out on our own Edison Motors page, kind of walking through the good points that Wes made. So if you want to check that out and see our response to a lot of that, it was very respectful, and it'd be worth watching if you watch Wes's video.
Okay, I'll put my flame suit on, guys, before I watch it.
No, it's good.
No, it's pretty good. I'll send it to you first before we send her out, and you can have a look, see what you think.
I'm not concerned. Hey guys, I'm gonna lose battery here, and I'm gonna have to go. So maybe it's a good place to wrap it up.
Awesome. Well, hey, thanks for meeting with us, and
Okay, let's do it again sometime. And if you guys need something from me, just ask. You know how to get a hold of me. So like I said, I'm on board. I want to see you guys succeed. Maybe it didn't come off that way, but I hope it did.
it was pretty harsh. I don't think we looked into the niche part of it. I wish you had said a little bit more about the niche and the vocational side where it might make more sense. But I think you did a very, very fair job of it.
Well, so my wife said I should have asked you guys before I made the video, which of course is correct. But she's a lot better with people than I am. So yeah, but we'll figure out some way to fix it.
Yeah. You can come up and do a collab with us and drive the truck and put it on your page and make everything good again.
Okay. We'll look forward to doing that.
Yeah. All right. Good talking to you there, Wes.
Thanks, guys.
Yeah. See you guys.